The genesis of the steel dolphin did not begin with the graceful erection of steel towers reaching into the clouds. It began with a violent, deafening assault on the Earth itself, to force a high-speed, multi-ton roller coaster directly through a live, aquatic apex predator habitat. Civil engineers were tasked with a deeply unnatural objective. They had to carve a colossal subterranean crater into the bedrock of Shanghai, creating a massive void capable of holding thousands of tons of high-pressure saltwater without fracturing under the immense mechanical stress of a screaming amusement park ride. The site was immediately swarmed by fleets of heavy-tracked excavators and colossal diesel bulldozers. The air was thick with the suffocating dust of pulverized rock and the relentless, mechanical roar of heavy industry as tungsten carbide teeth violently chewed through the earth. This was not a standard foundation dig. They were excavating a massive aquatic abyss. Once the colossal trench was ripped open, the structural reinforcement phase began, demanding an absolute mastery of marine-grade civil engineering. Thousands of miles of heavy ribbed steel rebar were meticulously tied together by high-altitude ironworkers, forming a dense, impenetrable metallic skeleton inside the dirt basin.
Okay, easy now, easy. We're good here, send the next one down.
Inspection complete for grid sector gamma. Notations show hairline fracture with significant efflorescence at the lowest point, recommending further analysis.
Over this immense steel matrix, engineers poured thousands of cubic meters of highly specialized, ultra-dense marine concrete. Standard concrete would quickly succumb to the corrosive, chemical onslaught of the artificial seawater, leading to catastrophic internal rusting of the rebar and eventual structural collapse. Therefore, this customized concrete matrix was infused with heavy industrial slag and chemical sealants, designed to cure into a monolithic, watertight armor capable of isolating the immense hydrostatic pressure of the shark basin from the surrounding earth. As the massive concrete leviathan cured, locked permanently into the ground, the engineering teams pivoted to the single most dangerous and technologically complex element of the entire mega-project, the high-speed electromagnetic propulsion system. Traditional roller coasters rely on the slow, agonizing mechanical creep of a heavy steel chain lift to drag a train to its apex before surrendering to the pull of gravity. The steel dolphin completely abandons this archaic methodology in favor of pure, uncompromising electromagnetic violence. To achieve a 0 to 53 mile/hour launch in a matter of seconds, technicians installed a brutally powerful Linear Synchronous Motor, or LSM, system directly onto the launch track. This is not a ride mechanism, it is a military-grade magnetic catapult. High-voltage electrical contractors spent grueling weeks wiring hundreds of massive, heavy-duty magnetic stators in a precise, linear sequence along the massive steel spine of the track. These stators are connected to a heavily guarded, multi-megawatt subterranean power grid that operates with terrifying electrical force. When the system is armed and the launch sequence is initiated, immense banks of supercapacitors detonate their stored electrical energy in a fraction of a second, flooding the stators with raw, alternating current. This violently rapid shifting of electrical polarity interacts with the massive rare earth neodymium magnetic fins bolted to the underside of the train. The resulting physical reaction is an aggressively repulsive magnetic wave that physically grabs the multi-ton steel train and violently hurls it forward with neck-snapping G. To sustain this terrifying kinetic energy and prevent the launch system from melting down under the immense thermal load, a massive network of liquid cooling lines constantly pumps freezing coolant directly through the stator housings, turning the launch track into a living, breathing mechanical beast, but generating 53 miles per hour of raw, kinetic velocity is utterly useless if the structural steel holding the train cannot withstand the resulting physical trauma. The fabrication and installation of the coaster's steel track was a masterpiece of heavy-duty metallurgical engineering, spearheaded by the renowned structural architects at Intamin. Every single piece of high-tensile steel track was forged in massive industrial foundries, heated to thousands of degrees, and bent with microscopic, laser-guided precision to ensure the geometry was absolutely flawless. If a single curve of the massive steel pipe was off by even a millimeter, the resulting high-speed vibration would violently tear the train's wheel assemblies to shreds. The installation required colossal, heavy-lift crawler cranes to hoist these massive, curved steel track segments 108 feet into the high-altitude skyline.
Easy, easy. Bring it down right there. That's good, lock it in. Easy now, easy. Hold it right there. A little bit to the left. All right, set it down slow.
Bring her down 20 centimeters easy. We're clear on this side.
Holding steady, watching the pins.
The vertical drop, the section, the vertical.
All right, bring it down slowly. Watch the alignment on sector 4. Copy that, coming down easy. We need more torque on bolt 12.
suspended precariously from thin safety harnesses high above the concrete abyss, wrestled with the heavy steel in the shifting winds. They used massive pneumatic torque wrenches to drive heavy, high-tensile bolts into the thick structural flanges, permanently locking the steel segments together. The track weaves into a terrifying, towering top hat element designed specifically to subject riders to maximum vertical G-forces before abruptly cresting and plunging them into a sheer, merciless vertical dive. The steel support columns anchoring this high-altitude track had to be drilled incredibly deep into the surrounding concrete podiums, heavily reinforced with massive steel base plates and industrial shock absorbers designed to swallow and dissipate the violent, swaying kinetic energy generated every time the multi-ton train rockets over the peak. However, the absolute pinnacle of this structural madness, the most lethal and psychologically imposing engineering marvel of the entire megaproject, lay waiting at the very bottom of that terrifying 108-foot dive. Before the massive concrete basin could be flooded with millions of gallons of water and populated with apex marine predators, engineers had to forge a secure path for the coaster to travel straight through the heart of the tank. They constructed a colossal, heavy-duty underwater tunnel, a structure that demanded aerospace-grade precision and deep-sea durability. This was not constructed from standard glass, which would instantly shatter under the immense physical forces at play. Instead, the tunnel was forged from massively thick, optically clear polymethyl methacrylate, a hyper-advanced acrylic polymer engineered specifically to withstand the crushing, relentless, and suffocating hydrostatic pressure of the ocean water pressing down upon it from all sides. The manufacturing of this massive acrylic tube required specialized thermoforming ovens, slowly bending the thick polymer sheets under immense heat to create a perfect, seamless cylinder that would not distort the vision of the riders or the sharks. But simply placing an acrylic tube underwater is not enough. The true engineering nightmare was sealing it. Where the massive acrylic tunnel meets the raw concrete walls of the basin, engineers installed colossal steel compression rings and heavy industrial elastomeric gaskets. These critical joints had to be flawlessly watertight while simultaneously remaining entirely flexible. When the massive, heavy steel train violently slams into the tunnel entrance at its maximum velocity of 53 miles per hour, it generates a massive concussive shockwave of mechanical vibration. If the tunnel was rigidly bolted to the concrete, these violent vibrations would instantly crack the acrylic, causing a catastrophic structural blowout that would instantly flood the coaster track and drown the entire system. Instead, the heavy elastomeric gaskets act as massive shock absorbers, allowing the entire underwater tunnel to microflex and breathe under the violent impact, effectively neutralizing the kinetic shockwave before it can shatter the tube. The final culmination of this $300 million industrial crusade is a functional test of extreme mechanical violence and sensory overload. Deep within the maintenance bays, the massive coaster train is subjected to extreme scrutiny. Heavy-duty polyurethane wheels, designed to grip the steel track with zero tolerance for slippage, are locked into the massive steel bogies. The heavy neodymium magnetic fins are perfectly aligned to hover mere millimeters above the launch stators. When the testing phase begins, the massive train rolls slowly out of the dark station and violently locks into the magnetic grip of the LSM launch track. A deafening, low-frequency electrical hum fills the air as the massive supercapacitors charge to maximum capacity. In a fraction of a second, the magnetic field detonates. The sheer, unadulterated force violently blasts the massive coaster forward, catapulting it from a dead stop to 53 miles per hour in a dead sprint. The train rockets up the massive steel spine of the 108-foot top hat, the steel structure groaning under the immense kinetic load. As it crests the absolute peak, the ground drops away completely, and the heavy train plummets straight down into the terrifying, gaping jaws of the concrete abyss. With a deafening roar, the train violently pierces the entrance of the submerged acrylic tunnel. In a fraction of a second, the blinding sky is replaced by dark, heavy water. The riders are completely surrounded by the crushing ocean, apex predators circling just inches away from the thin acrylic shield, separating human engineering from the absolute depths of nature. As the train rockets out of the tunnel and hits the massive magnetic brake run, the violent, kinetic fury of the steel Dolphin is brought to a sudden, silent halt, completing a flawless, brutalist feat of high-speed structural engineering that proves humanity will stop at absolutely nothing to bend gravity, speed, and the raw power of the ocean to its unyielding will.